in base 2 plus 1 0 in base 2 also equals to 1 0 0 in base 2, right? Well, because I'll explain why. Let's see if it's correct. First, we need to see what's the 1 0 in base 2 equals to. So we first put it into the decimal number, which means we put it into the expanded form. So this means it's 1 times 2 to the 1's power, because this is in base 2, with 0 times 2 in 0's power, because in base 2, which equals to 2, because the other are zeros. We only have 2 left. So now we know that 1 0 equals to 2. 2 plus 2 equals to 2 times 2. But why, right? Because 2 times 2 equals to 2 plus 2. This 2 means how many times does this 2 need to plus its own self? Because multiplication equals to that. So, and also 2 times 2 equals to 2's power. So, put it back into the put it back into the
binary.
Yeah, the binary expansion. We put it in order, into a sequence. So putting expanded form, it is 1 times 2 to the 2's power plus 0 times 2 to the 1's power plus 0 times 2 to the 0's power.
How can you convert it back into the binary system?
Well, we put it into the expanded form.
And then
we put it into the notation.
Okay, how can you make the notation in the binary system?
Well, we just put the coefficients together.
Yes.
So we have a 1 with a 0 and a 0.
Okay.
So let's see if it's correct. So this is 1 0 0 in base 2, and this is 1 0 0 in base 2 as well. So that's why this is correct.
Very good. And then
Okay, and then we need to learn about this, which is the whole,
so generally.
Yeah, general. So we have 1 0 m 0.
So m means?
And m means how many zeros are there.
Okay.
And don't forget, m can be any number.
Yes, and
can be
n.
0, 1, or whatever.
And n here means?
And in here, it means
n.
N. And here, in here means
The power.
Yeah, the power.
Okay. Yeah, can you show me why this expression is correct?
Yes, okay. So why does this plus equal to this mean right?
Right.
Well, because we not like the normal way we did. We also convert the expanded form. Except, firstly, we don't know how to convert expanded form. We first put this in.
So what is this?
This is the base B expanded.
Yeah, expanded form in base B.
Yeah, the expanded form in base B. But we put it into the notation first. Notation. So we know from AM to A1 we have n number. N coefficients.
Good.
Because we count from A1 all the way to n numbers.
Yes.
Okay, don't just leave it when n equals to n. Okay, or we can go from 0 and count to an minus 1. We also have n numbers. Just we add 1. So, back to this one.
So it means altogether there are how many coefficients?
N plus 1. Because don't forget the
A0.
Yeah, A0. So put them all together from here to here. We have n plus 1 coefficient.
Right.
Okay, and back to this.
Yes.
There are zeros in here.
Yeah. So
Or shall I say coefficients?
yeah. So here there are how many coefficients altogether?
So here altogether there are m plus 1 coefficients.
Yes.
Or numbers.
Yes.
So this means that n, which goes to m,
Right.
and
Because they
because they mean the same thing.
Yeah, they have the same coefficients.
Yeah.
In the notation form.
Yes. Okay, so this means that A m, which is the first number, equals to 1 here.
Yes.
D equals to 2 because this is in base 2
Right.
expression. And N equals to M, which is said earlier.
Yes.
And you already know. So that's why so now we know all of these list of things, we can put it into the expanded form.
Yes.
What
We'll go back
decimal
to
number?
we'll go back to the expanded form. And what else can you get?
So now we can get this, which is this is expanded form.
No. So we go back to this.
Yeah.
And we can get what? So we can convert this into the
base B expanded form, or base B.
or the decimal number.
Yeah, or decimal number.
So what is the decimal number?
So the decimal number of this is 1, which is AM, which I mentioned earlier.
Yeah.
So we know AM is 1 times 2 because D equals to 2, which and M plus
no,
1.
Here.
Oh, yeah. So it is 1 times 2 to the m's power. This
Because M
Be-
equals
because N equals to M.
right.
And we don't know what M equals to, but we know that what does it mean. Plus 0 because we know the other objects are all 0.
Yes.
0.
So
which equals to 2 to the m's power because all the others are 0. None of them is a 1 number.
yes.
This is a 1 number.
Very good.
Because 0 times whatever any number is 0.
Very good. And how many times they are added together?
How many times they are added together? They are added m times.
I mean this. So this converted into the decimal figure is
Sorry, is this? I have a yarn.
it's
It's 2.
to the m's power.
Yeah.
And how many times will this number be added together?
It will be added together 2
Added together how many times?
to the n's power.
Very good.
The times.
Yes.
So now we know what is this equals to. It's time to find what is at. Why it is.
Yes.
So-
So this equals to
So this equals to 2 to the m's power times 2 to the n's power.
Can you explain?
2 to the n's power means how many times does it have to plus its own self.
Yes.
And 2 to the m's power times 2 to the n's power equals to 2 to the m plus n's power.
Very good.
Because we can't say we have 2. We can't say we have 4 to 2 to the m plus n's power. We can't say
Yeah.
4.
Can you explain what does this mean?
Yeah, we can. So this means the power equals to m plus n.
Yeah, it means 2 times 2 times 2. How many times?
M plus n times.
Very good.
Remember, this is m, not r.
Okay.
Okay, so now we have this. We need to convert it back into the notation or expanded form.
No. Oh, okay, you want to convert it back into the expanded form?
Or because we evaluated expanded form, we couldn't get the notation.
Mm-hmm.
So if the expanded form is 1 times 2 to the m plus n's power.
Yes.
This is n, not r.
Yes.
Plus 0. Blah, blah, blah. And then the coefficients in order, which is called the notation. We have 1, 0, blah, 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 blah,
Yeah, how many zeros?
m plus n zeros. And don't forget the subscript, or else someone will make any number. So the subscript is 2 because this is in base 2. Let's check if it's correct. Yes, it surely is.
Yes. Very good. It means this equation is correct.
Yes.
And then let's suppose if n equals
Okay, so now we're going to learn this. Just 2 more chapters to go. Okay, so if we're going to learn another one, if m equals to 0, and
so we look at a specific cases.
so if m equals to 0, and n equals to 2. Remember, n means how many times that the number have to take. And
So you can, yeah. So in this case, n means.
In this case, n means how many zeros are there.
Yeah. So
And n means how many times that this number have to plus.
No. Here.
Yeah. And n in here means the power.
Yes. And the answer is.
And the answer is that n equals to 0, which means there is no zeros.
Yes. So this is 1.
Yeah. And remember, so which is here, not this. And also we have to add its own
Add it
self.
how many times?
2 to the 2's power times.
Yes. And the result is, according to this equation.
According to this equation, it equals to 1, 0, 0,
Yes.
n plus n 0.
Equals n plus n equals to.
And n plus n equals to 2.
So you will have how many zeros?
So this means it will have 1. It will have 2 zeros.
Very good. And then another case.
Yeah, this case is very I need to get. And don't forget to put on your thinking cap. Or thinkies.
In this case, m equals to 1. So the number is.
So the number is 1, 0.
Because it has only 1 0.
Yeah.
And in.
Here. Sorry.
And in this case, n equals to 2.
Yeah.
So
in this
they
case,
need to be added how many times?
4 times. Or 2 to the 2's power times.
Yes, and the answer will be m plus n. So the answer should have how many zeros?
So the answer maybe should have 2 zeros. Or
Here have how many zeros?
on here it might be have 3 zeros.
Oh, so you have 3 zeros in this case. I think the two specific cases can help you to do this.
Yeah. And don't
Can you-
forget, this is
here.
a parenthesis.
Yes, can you tell us why and how?
Well, first we get this. So 1 in base 2 plus 4 times.
Yes.
And
how can you do that?
how can we do this right? Well, because we know that 1 equals to 1 0 plus 1. We can do it in the
binary system.
Yeah, in binary. You can do it in the algorithm if you please. Anyway, I'll draw the algorithm to make you see if it's correct.
Yeah, this is the algorithm.
Yeah, sorry.
Yes.
Okay, so we have 1 0 in base 2 plus 1 in base 2, which equals to 1 0.
So you substitute
So I substitute 1 0 into
1 1.
yeah 1 into 1 0 plus 1 plus 1
Yes,
in base 2.
In binary
Yeah.
system.
And don't forget we have 4 11, so we need to recycle this 4 times.
Yes.
So I will just skip.
Yeah, and how you arrange this into this?
Because we put all the 4 tens in the group.
Okay.
And then
so
we
there are
put-
how many 1 0?
So how many 1 zeros are there? There are 4 1 zeros.
Okay.
And don't forget there are 4 ones too.
Right.
So we know that there are 4 1 zeros, which equals to
Yeah, we have already found out 4 1 0 added together is
1 0 0 0.
good. And for 1
And for ones, we already know 4 ones is equals to 1 0 0 in base 2.
yes. So we can rewrite this expression
Into 1 0 0 0 in base 2 plus 1 0 0 in base 1 0 0 in base 2, which equals to 1 1 0 0 in base 2.
why?
Well, if you don't sure, look at the algorithm. It's a little bit like a big box of.
So how can we do addition in binary system?
Well, we do it like this.
Like we do in
In a normal, in a base 10 expand, in a base 10.
Very good. So we just put the digit in column.
Yeah, columns. Well, if you might be embarrassed, I'd have to draw the columns. Okay, so we have 0 plus 0, which equals to 0. No, 0 plus 0, 0. Don't forget that 0. And 0 plus 1 equals to 1. And 1 plus 0, because this is 1, 0, 0, not 1, 0, 0, 0, 0. We have 1 plus 0, which equals to 1. So which equals to 1, 1, 0, 0. So the answer is 1, 1, 0, 0 in base 2.
So good. Thank you.
I hope I should put my earrings on. Bye bye.